going on page 48 when we're done. So we have found zeros already. We know how to find zeros. That is not anything new to you at all. And so we're just going to talk about some terminology here. And terminology is important because if you don't know the different terms when you're asked to do something, you may know exactly how to do it. You just have no idea what they're talking about. And if they worded it differently, it's something that you could actually do. So for zeros, the x-intercepts of a function are also called zeros. Okay, that's something hopefully you already knew. Right. So a polynomial function of degree n can have at most n real zeros. Just because I have a polynomial that is a degree 6 doesn't mean 6 real zeros. Okay, I might only have 4 real zeros, not 6. And the key there is real because you also have complex numbers, imaginary groups. You talked about in algebra 2, so those, when you put them all together, the total number should be n, but not the real ones necessarily. So an even number or an even degree polynomial has an even number of real zeros. So if I have a 6th degree polynomial, I could have 6 real zeros, or I could have 4, have 5. That's an odd number, right? And then an odd degree polynomial has an odd number of real zeros, and with the even, real zeros, which is so goes along with whether or not the degree is even or odd, how many real for us when we start trying to figure out how many we have and things that aren't factored for us already. Let's talk about the linear factors and solutions, which is what we've been looking at and what we can find pretty easily for ourselves right now. The solutions to the equation f of x equals 0 are the zeros of the function. They are also called roots. So we could call them the roots, the solutions, the zeros, the x's, the x-intercepts, all refer to the same thing. That's important to know. Years ago, long time ago now, before the STAR test, there was the tax test. And y'all were, I don't know if y'all ever did tax when you'd have been ever a thing for you or not. But anyway, on the 10th grade tax test, they said it was a quadratic, some algebra on it, and it said find the roots of the function, whatever it is. Huge percentage, the majority of the students in the state missed that question. Like, everybody just missed it. It was easy. It was easy to find, but used a whole in the Algebra 1 classrooms. Like, they weren't using that. They just said solve the quadratic or find the it. But when they said roots, they're like, what the heck's a root? I don't know what that is. So why, it was an easy question, but if you don't know that roots, solutions, zeros, those are all the same things, then you know what they're asking. At this point, hopefully you know, well, that was the focus of everybody now, that those are all the same thing. But in a lot of other stuff, when we talk about the terms, it's important to know and make some of those connections. All right, so if x equals c just being a constant, it's just a number, so x equals 5, the solution to the equation, then x minus c is what we call a linear factor. And it's linear because the exponent on x is 1, right? And linear factors can be found by a polynomial. That's one way. So we have this first one, x cubed plus 5x squared minus 24x. Factor. We can find that by factoring the polynomial. So we're going to do that, and we'll use some of this blank space over here. I'll just rewrite the expression. We get x cubed plus 5x squared minus 24x. So what should be the first thing that I do? Great common factor. Is that I can factor out? Yes. What is it? X. Well, it's just x. So x, and then that leaves me with x squared plus 5x minus 24. Now that I've gotten GCF out, now I have a quadratic that's much less intimidating than a cubic, right? So I can take this quadratic and factor it into two binomials. So a is 1, I know this is x and x. Since this is negative, what does that tell me about these signs? They're opposite, they're different, so plus and minus. Then I need to the positive one has to be bigger, so it's positive 8 and negative. Okay with that? We can factor that, right? We're these things now. So when we have this, this equals x times x plus 8 times x minus 3. So it says, what are the linear factors? Well, we have 3 linear factors. They are x, x plus 8, and x minus 3. And then, is it pretty easy to figure out the zeros? Yes. So my zeros, now since it says 0, how do I have to write this answer? Pairs, right? If it, what when it says what? X intersects. Good. So this is x equals, and then in my little set notation, I'm going to have 3 answers in there. The smallest being what? Negative 8, right? Because it's whatever you would set this equal to 0. Hopefully, we're past having to actually do that. I mean, you should have been taught, that you would do x plus 8 equals 0, and then you solve for x. Well, that's going to give you a negative 8 there, and then 0 and 3. Okay, and there are your zeros. Easy enough? Any questions at all? We good?
Doesn't matter if you just copy them individually.
Is it the same thing separately? Yes. However, we're going to longer and longer, so we want to get used to doing that. When you have like 10 of them, which will at some points, you don't want to do it. Well, does that make sense? You are saying the same thing, but this is really what we want to start with. It's a good question. Anything else? Skip number 1 because it's pretty much the same. And I want to move on to number 2 because there's a lot of these. I don't know that we need to do every single one of them. So, because on number 1, we would still factor out that GCF, right, and then factor it. So, same thing. So, let's look at number 2. Is there a GCF here? Yes, there is. So, it's still a GCF. But what's the GCF? X. So, I get x times, that leaves me with 2x squared minus 5x minus 3. Now, what's the main difference between this and the one we just did? But the best way. So I need to separate this middle term. I need to split that. So this x stays on the outside, right? I do 2 times a negative 3. It's going to give me a negative 6. And so the sides are going to be opposite. I'm still going to have my 2x squared here. And then I'm going to have plus some x and minus some x. But together, they have to give me a negative 5, and they'd have to multiply to give me a negative 6. So what are the 2 numbers? 1 and negative 6. Good, and it would have to be negative. So I could do plus 1x, or just x, minus 6x, and minus 3. Everybody okay with that? Stop me if you got a question. I lost you, all right? Now, at this point, I don't want you to get lost. Not you can keep track of what, because we have to keep this x on the outside, right? So I'm going to have a bracket here because now I'm going to group and I'm going to factor something out of these first 2 terms. I'm going to group these 2 together and these 2 together. What do I factor out of the first 2 terms? X. So I'm going to factor an x out, and that leaves me with 2x plus 1. What would I factor out of these 2? Negative, get negative 3, and that would leave me with 2x plus 1. And we would expect for those 2 things to match, right? The brackets are just there for that one step so that a bunch of parentheses don't confuse you, because then my brackets are going to disappear, right? And so then I want y'all to tell me, because officially when you factor this out, the 2x plus 1 goes out in front. But I've heard multiple times over the last week or so that I would always put the x minus 3 first. It doesn't matter either way, right? What are y'all more comfortable with, putting like x minus 3 first or 2x plus 1? You do it both ways, and it makes sense both ways, right? Because officially factoring that out, I just want to make sure I wasn't confusing anybody. All right, so x, and then I'll just make that 2x plus 1, and it doesn't matter what order it's in, and then x minus 3. Okay, so we have it all factored, right? Once I have it all factored, then I can throw my f of x back in there. Glad I didn't do that one because I went into that space. Because part of it is the factored form. It is factored. It says find the zeros of the function below by factoring. So we factored it. Now we got to find the zeros. So a little set right here. I'm going to have 3 numbers in there. And what would be the smallest one? Okay, so this is going to be a positive 3, right? This would be negative 1/2, right? So this is going to be a negative 1/2, 0, and 3. Now, if you think that you're going to mess up on signs, because signs are the things that most people are going to mess up on if they mess up on something. If you need to write down 2x plus 1 equals 0, make that 2x equals negative 1, so x equals negative 1/2. There's absolutely nothing wrong with that. I just think that most of us are probably at the point where we can just take these straight out. Just make sure you're fixing your signs when you do that, because that's what could get you in trouble. All right, and then there's our answers. We okay with that? Any questions at all? All right, let's try number 3. So the fact to factor number 3, do you like the way number 3 looks? Yes? Okay, that's a good answer. It's x to the 4th power. That's not the deal, right? I can treat this like what? And so a is 1. That's good. I can factor it. I should be able to put it in 2 binomials. Instead of x and x, I have x squared and x squared. What I know is, since this is positive, these signs are the same. Since this is negative, they're both negative. Multiply to get 4. You're on 2 and 2 or 1 and 4. And what would work here? 1 and 4 or 4 and 4. Everybody good so far? Can I keep factoring? Yes. What are these things called? When it's a difference of squares, hang on, my board's okay. When it's a difference of squares, this x minus 1 or x squared minus 1 is going to become x plus 1, x minus 1, and then this x squared minus 4 becomes what? Good, x plus 2 and x minus 2. And you have it factored all the way, and it's not really that bad. There was you end up with more terms, but we're right. The more you practice, the more comfortable you're going to be with it. So I have it factored as much as I possibly can. I got to find. So my smallest will be negative 2, and then I have a negative 1. But then I also have a positive 1, right? This minus 1 really becomes plus or minus 1. And because I have a negative 2 and a positive 2, we're going to make that plus or minus 2. Because again, we're going to have somewhere we got to list out a ton of stuff. And the more you can condense, the better. Okay? We good with that? We okay with that? All right. We're good. Okay. Questions? All right. Let's look at 4. Because 4, it has x to the 4th also. But a is not 1. Do I have a GCF? No. Okay, so that means I'm going to need to do grouping. So I'm going to need to split this middle term. So this is still going to be 9x to the 4th. I multiply 9 times 4 and I get 36. The signs are the same because this is positive. This is negative, so they're both negative. So that means I need them to multiply to give me 36, but combine or add to give me a negative 37. What would that be? 36 and 1. So it would be negative 36x minus x plus 4. And if you want to put minus 1x there, if that helps you, that's absolutely fine. Doesn't matter. I got to do my grouping. I don't need brackets here because I didn't have a GCF out there. But in my first 2 terms, I'm going to group those. What do I factor out of the first 2 terms? Oh, what did I do wrong when I split that up? Look at what I wrote in orange. What's wrong with that?
Oh, you didn't put square.
Yes, square. Because the 36 and the x should give me negative 37x squared, right? And I left my squareds off. Does that make sense to you? Because that was x to the 4th, right? All right, so when I factor this out, what am I going to factor out? 9x squared. Good. So that leaves me with x squared, then what? Minus 4. What do I factor out of the last two? -1, right? With that 1 there, -1. And that leaves me with x squared minus 4 also. So then I'm going to get x squared minus 4 times 9x squared minus 1. Okay. Difference of squares, because x squared minus 4, we just did that. Is the second one a difference of squares also? Can you take the square root of both? Yes, it actually is. Okay, good. So this becomes x plus 2, x minus 2, and then this one, what would it be? 3x plus 1 and 3x minus 1. That's all factored out. That is my f of x. So then when I solve it, my x is, well, this is going to give me plus or minus what? 2. And then these are the same with different signs. So this is plus or minus what? 1/3. Okay, so I've got plus or minus 1/3 and plus or minus 2. Okay. Well, we are, but at the same time, it kind of depends on which one you think is first. And sometimes when some of them have plus or minus and some of them don't, this is actually okay, but we should be least to greatest. But when you've got the plus or minus in there, sometimes there's one that has it and one that doesn't. I should have put the 2 first. You're right. So because it still would have been, yeah. But thank you for pointing that. Yes, you're right. All right. I'm not going to erase it though, so it's fine. All right. Let's flip this over on the back. Let's see. Let's see. I think we can skip number 5. Let's just do number 6. All right, do I have a GCF here? No, okay. And the easiest thing to do usually is look at the smallest. Well, 3, clearly I can't even divide 5 by 3, so I'm done there. This is cubic. What kind of process do I do here? What am I doing? Grouping, okay. So it looks kind of yucky, but it's not that bad. I'm going to group. So this is going to, what can I factor out of the first one? 4x squared would be my GCF, good. So 4x squared, and then that's going to leave me with 5x minus 3. Then what do I factor out of here? -1. That leaves me with 5x minus 3. Okay, so then that gives me 5x minus 3 times 4x squared minus 1. Can I factor this some more? Yes. Can I do anything with this first factor? No. So this is still just 5x minus 3. And then is this a difference of squares? Yes, it is. So what would this first thing look like? Good. 2x plus 1 and then 2x minus 1. And then that's factored all the way, so f of x. My x is, what's the smallest one I would have? It's or the -1/2, and then that would make plus or minus because I got 2 of them. So plus or minus 1/2, and what would the other one be? 3/5. Okay. And that's my answer there. Mm-hmm. Okay, everybody good? Any questions? All right, so let's talk about multiplicity. Sounds like a very fancy word. It says multiplicity of a 0 is the degree of its corresponding linear factor. So the degree of its corresponding linear factor. And we have looked at that already when we sketched. Okay? And so let's look at this and see what happens with our multiplicities. So let's factor number 7. Is there a GCF here? X. So this would be x times x squared plus 10x plus 25. Does this look familiar from yesterday as a special case? What can you check to see if A is 1, if I can do what to this term, does it give me something? If I divide that by 2, I get 5, right? Is 5 squared 25? Okay, so then this is a perfect square trinomial. Remember that? And so we don't have to worry about the two numbers and write it all out and whatnot. So when I get this, now you can, and it's fine. We could do that. You would end up with x plus 5 and x plus 5, and then you would have to put them together. But because plus 5 squared, and you put your squares in the right place. Does that make sense to you? Saw that yesterday. It says find the zeros and multiplicities. So since we're having to describe them separately, we're actually not going to put these in the set notation just because we have to say something about them. So my smallest one is what? -5. So I can say that x equals -5, and it says the multiplicity of a zero is the degree of its corresponding linear factor. Linear factor, this is the degree of that, is a multiplicity of what? 2, because there's 2 of them. What's my other 0? 0. And this has a multiplicity of what? No, it does. 1. Yeah. 1. Here's something. Okay. With that? Do you understand what it means by multiplicity? When we were sketching this right here, what would happen at our polynomial for this? It's a bounce, right? And it's because we have that multiplicity of 2. Mm-hmm.
If the answer was x equals 1, would it be multiplicity of 0? Anything to the power 0 equals 1.
Yes, but 1 is not a 0 for this function. Does that make sense? Like you'd have to have it, you have to find the zeros and then determine their multiplicity. So you really wouldn't have a multiplicity of 0. Well, you have a multiplicity of 0 for an infinite amount of numbers, but that's not anything we would even worry about. Okay. All right, so let's look at this next one. What can I factor out here? Not just x squared, but what? Negative x squared. So this is going to give me negative x squared times x squared plus 6x minus 9. Okay. So can I minus 6x? I was like, dang, what did I do wrong? I didn't fix my sign. Good catch, good catch. Because otherwise I can't factor that. Because I factored out a negative, that would be a negative 6x plus 9. I was like, oh dang, this one doesn't factor. Okay, so what I know here is that this means the signs are the same. This would mean that they were both negative. So if you don't catch that you have something special here and you'd factor it, we do negative x, and I factor it like this. This is x, this is x. The signs would both have to be negative. What goes in there? What are my numbers in here? My only choices are 3 and 3 or 9 and 1. 3 and 3, right? And it's the same thing, and then I have to finish this and say that that is x negative x squared times x minus 3 squared. Okay? This is a perfect square trinomial because I can take half of this and square it. I could have gone straight to here, but you may not always catch that you can do that, and that's okay. So if you come up with something like that, you need to rewrite it, and this is your f of x. Okay? So then I have to use my multiplicities, or I have to find my zeros. And what's my smallest zero going to be? 0. So x equals 0. What's the multiplicity? 2. Good. Multiplicity of 2, because that's x squared. It's not a difference of squares. Difference of squares would be like x squared minus 9. This is a perfect square trinomial. Does that make sense? Okay. And then the other one would be x equals 3. That would have a multiplicity of what? 2. All right, I'm letting you abbreviate the word multiplicity.
Oh.
Okay, I was like, what do you want to abbreviate? Okay, that's fine. All right. So then we've got, we're going to have this. It says write this in factored form and graph the function. Then look at how the multiplicities affect the graph. All right, so I'm going to give you the factored form. It really, factoring is not that big of a deal, and but just because I want to have time to talk about everything else, I'm just going to give it to you. So f of x is equal to, that would be x times x plus 2 squared. Because I think you're capable of factoring it, but I want to spend time talking about the other stuff. So it says, so what happens to the graph? Well, when we go to sketch this, our zeros, right? And what would our zeros be here? In -2. So -2 and 0, those are my two that I have, right? So here's -2, and then here's 0. What's my y-intercept? 0. And then this has a degree of 3. So what does my end behavior look like? Down, up, right? So my end behavior looks like this. So if I'm going to go and sketch this in here, right? And I know that what's happening here? This is a bounce, right? So this is my bounce. So I start from down here at -2 is where my bounce is. So I start down here, it bounces, and it comes back up, and it looks like this, right? That's how we would sketch that. So it says, when the multiplicity is even, called it a bounce, right? There's a word for that. It's called tangent. Remember, tangency. Okay, you only intersect at one point there. When multiplicity is 1, like here, okay, then the graph just intersects the x-axis. Mm-hmm. Oh, tangent and I spelled, I made up a word. That's not a word. No, I'm sorry. Dang it, I didn't even realize I made something up. Tangent, that's how you spell it right there. It's all one word, tangent. Okay, so x, or it really just passes through. When multiplicity is odd, greater than 1, this has a point of inflection. Remember that? Point of inflection on the x-axis. So this is what we would call our wiggle, right? So this intersection is really just, it passes through it. It passes through it here too. It intersects it here too. It just intersects it at that wiggle, all right? This bounces off when it's even. If it's 1, it just goes right through. Odd, we have the point of inflection. Okay, does that make sense? Well, let's look at how we describe that. We've already kind of looked at that stuff when we sketched. So, our rows, what's the smallest one here? -4, and then 1, and then 3/2. So I have -4, 1, and 3/2. So for my -4, what's the multiplicity? 1. For 1, what's the multiplicity? 2. And 3/2, the multiplicity is 2. So the effect here, when it's just the 1, it just intersects, it just passes right through. Okay, this is a bounce, but we don't want to put bounce. We can put the real word, which is tangent. It is tangent to the axis. You should have learned all about that in geometry. This is tangent also. Okay, it only intersects at one point. Everybody okay with that? We're good? All right, so I want you to look at number 10. Are you capable of factoring this? Yes, I know you are, but so I'll just give you the factored form. First of all, what's my GCF? X to the third. So x to the third, that would leave a quadratic, which you're totally capable of factoring, and it would just be x plus 4 squared. Okay, I don't want to take the time to factor that because I don't want to be doing this at the last second. So my zeros then, what's the smallest one? -4, and then 0. So -4 and 0. What's the multiplicity of -4? 2. What's the multiplicity of 0? 3. Okay, so when it has a multiplicity of 2 or it's even, then what's my effect? It's tangent, which is the bounce. And I want you to think about bounce so you can see in your mind like what's happening. But it's tangent. It just intersects the axis of that one point and comes back. And then when the multiplicity is 3, the point of inflection. Good. Which is a wiggle. And again, something I want you to think about. But point of inflection is actually the actual word. Okay. Are we good? Questions? So really this is more factoring, finding zeros, which you can do, and then explaining the multiplicity, which we really kind of already talked about. Make sense? We good? Any questions at all? Ask me if you got questions. Don't just sit there because you're probably not the only one thinking it. Are we good? All right. Go ahead and glue this in so not wait until the last minute.